Bismillah. Okay, good morning class. So today we're looking at exercise 4.6 on page 103. Exercise 4.6 on page 103. This is the first video of this exercise. So we are told that in the diagram, A is a point negative 6 and 7, B is 6 and 3, and C is negative 4 and negative 3. The first question says, determine the coordinates of M, the midpoint of CB. Okay, so the midpoint, which is M, is x1 plus x2 over 2, y1 plus y2 over 2. Okay, you must familiarize with yourselves with these formulas. So it's the midpoint of CB, so it's going to be negative 4, x1 plus x2, which is 6 over 2, y1, which is negative 3 plus 3 over 2. Okay, so the M gets negative, this 2 is 1 and 0. Okay, so I put 1 and 0. I start populating the diagram. Okay, as I did in analytical and Euclidean geometry, I do the same here. Okay, so at one glance you can see exactly what's on the diagram, what you've calculated already. Then this is the length of AB, which is this length here. So to work out the length, it's distance formula. So it's x2 minus x1 squared plus y2 minus y1 squared. Okay, so you're going to go, it's going to be the square root of negative 6 minus 6 squared plus 7 minus 3 squared. Okay, so we put that in our calculator. It's simply going to give us negative 6 minus 6 squared plus 7 minus 3 squared. Okay, which gives us 106, the square root thereof. It's going to give you 4 root 10. Okay, 4 root 10. Let's look at C. So I'll put 4 root 10 here. Okay, in C they want to know, calculate the gradient of AM. So that's this gradient here, the gradient of AM. So for a gradient, it's going to be y2 minus y1 over x2 minus x1. Okay, so it is for AM, so it's going to be 7 minus 0 over negative 6 minus 1, which is 7 over minus 7, which is negative 1. So the gradient is negative 1. Okay, let's look at D. In D, they want you to calculate the equation of AM. So y is equal to mx plus c. But we know the gradient of AM is negative 1, which now implies that y is equal to negative x plus c. Did I have to write this? No. So of course we substitute the point lying on this graph, which is m, 1 and 0. I could have substituted negative 6 and negative 7. It's no problem, because both of those points lie on the graph. So c is 1, so therefore y is equal to negative x plus 1. You see, does that make sense? Yes, as you can see, it's approximately there, your y-intercept, which is your c value, which is 1. So the equation of this graph is y is equal to negative x plus 1. Okay, let's look at E. Each question says calculate the size of M2, the inclination of AM. So M2, which is this angle here, we need the gradient of that line. So the gradient of, so tan of M2 is equal to the inclination of AM. So tan of M2 is equal to negative 1. Arctan of that gives you negative 45. Plus 180 gives you an answer of 135 degrees. Okay, so that's 135 there. Then CEF, in F, the question says determine the inclination of BC. So if you're looking at BC, in other words, we're working out M2. So tan of M1, tan of M1 is equal to the gradient of BC. Have I worked out the gradient at this point? No. But I can work it out at this point because I have 2 points there. So that will be changing y by changing x. y2 minus y1 over x2 minus x1. I don't write it down again because I've just written it down once before. So it's going to be 3 minus 3 over 6 minus 4. Okay? Which gives us 6 over 10, which is 4 over 3. But we don't need to simplify that because we're going to punch in the calculator anyway. Arctan of 6 over 10 gives us 30,96. It says correct to the nearest whole number, so it's 31 degrees. Okay. If in G they want you to calculate the size of AMB. So let's just highlight what AMB is. AMB, which is this angle here. Okay, so what we do is we say, okay, we can say M2, so AMB is equal to M2, which is the big angle there, minus M1, which is the smaller angle there. That will give you AMB. I have M2, which is 135 degrees, minus 31 degrees. I think it's going to give you 104 degrees. Let's just check. Not 180, but 135 minus, 104. Okay, to the nearest whole number. Okay, in question 3, we are told that P, which is negative 5 and negative 2, Q, which is 3 and 6, and R, which is 4 and 3, are vertices of triangle PQR. Okay, first question, A. The question says, I'll just put A here. The question says, prove that RQ is equal to RP. Now, to prove that RQ is equal to RP, we're going to do distance formula. So the distance of RP, we could start with RQ, doesn't matter. It's going to be x2 minus x1 squared plus y2 minus y1 squared. So P, which is this point here, so it's going to be minus 5 minus 4 squared plus minus 2 minus 3 squared. Right, let's put that in the calculator. So that is going to give you the square root of 9 squared plus 1 squared. Okay, it's going to give you the root of 82. So if we can get the length of RQ to be the same, we've done the job. So we go now RQ, the distance. I don't write the formula down again. So it's going to be R, which is 4, minus Q, which is 3 squared, plus negative 3 minus 6 squared. Okay, that's again 1 squared plus 9 squared, which is the square root of 82. So we can say therefore RP is equal to RQ, which is equal to the root of 82. Okay, there we just proven what they asked us to prove. Let's look at B now. In the B part of the question says, give the coordinates of S the midpoint. So how do you work out midpoint? x1 plus x2 over 2, y1 plus y2 over 2. So S, so it's going to be negative 5 plus 3 over 2 and negative 2 plus 6 over 2, which gives us S to be a coordinate of negative 1, okay, and 4 is 2. So S is negative 1 and 2. Alright, let's look at C. For C, prove analytically that RS is perpendicular to QP. So to prove that points are lines are perpendicular, we prove that the product of the two gradients is negative 1. So if we're looking at RS, which is this here, so it's going to be y2 minus y1 over x2 minus x1. So for RS, it's going to be 2 minus 3 over negative 1 minus 4. So that would simply give us 5 over negative 5, which is negative 1. Okay. So now we work out the gradient of QP. Again, changing y over changing x. I don't write the formula down again, So it's going to be 6 minus 2 over 3 minus 5. So if you look at that here, it's going to give you 8 over 8, which is 1. So what do you notice now? We can conclude since the gradient of RS times the gradient of QP equals negative 1 times 1, which is negative 1. Therefore, RS is perpendicular to PQ. Okay. If they had asked parallel, we proved that the gradients would have been equal there. Okay, I'm going to the next video.